The first project I was given by Martin was to do the kinetic marble funnels, and he gave me a list of things that he wanted to happen, which for the most part I understood it as when the marble comes into these funnels, I want it to move. And I had been looking at a bunch of kinetic sculptures at the time, and so I came up with all these crazy concepts that would both dampen the marble as it comes into the funnel and guide it into the tube, and also do like all kinds of different movements. And I got about halfway through this when Martin was like, I like what you're doing, these are cool concepts, but they're not what I want to go with. So we're gonna do this shape, and it's going to be much closer to the original concept that I sent you.
So I'm Jacob LaRocca. I am an electromechanical engineer. I work in the space industry right now. Martin didn't like the way the funnels looked in his original marble machine. Rather, he didn't want to keep that aesthetic for the new one. I 3D printed the first one and used some wire that I had laying around and did a test. Martin liked the motion. And so he said, okay, let's move forward with this.
So I'm Tim Keller. I have a weird background. I'm trained as a winemaker, and I have a business degree. So when I got onto the funnel team, they had already started designing a lot of the things with wire and with hinges. In terms of the design, I think my biggest contribution was the aspect where we're using the spring as a hinge, as well as with the design. I did all the fabrication for the bodies of the hinges. So they were all stainless steel, which was difficult. There's a learning curve. So the milling machine I have, which is behind me, is a Tormach, which is a very popular machine, kind of entry level. Precision's pretty good, but it doesn't have a whole lot of horsepower. And with stainless steel, what you want to do is you want to take a big bite out of the chunk of stainless steel. And with small bites, the stainless work hardens. You end up breaking a lot of end mills. So this end mill, this end mill, this end mill, this end mill, which has two sides, and this one. This is like $300 worth of end mills that I wore out. We got it done. Yeah. The challenge is going to be welding all the wires together. And that's squarely on Martin now. We had Ecco to help us, and she ended up, because I was so late, she ended up not being able to do that. And so now Martin's going to be brazing stainless steel wire together, which is going to be fun.
So Martin contacted me and asked me for essentially a jig, like a wooden template to put all the wires on to hold them in place while you're welding them together or brazing them together. And so I took their model that team was working on at the time and made like this organic shape that fit inside. And then I cut out all the little spokes out of it and divided it into slices so that you could machine it out of thin slices of plywood and then kind of stack them together. So I'm pretty sure that was made and worked, maybe slightly altered as most things are.
My name is Ecco. I'm an artist, engineer, prototype fabricator. So my job was to help form how the funnels were designed so that they could be executed at all, let alone sort of beautifully and easily. The funnel project is interesting because Martin wanted an actuating flourish that wasn't necessarily required to help the machine do its job, but was designed to signal the machine doing its job. There are 11 funnels of the same size, and each one of them have an array of tines that are symmetrical across the center. And so they each have somewhere between 11 and 20 unique shapes, and each one needed to be sort of perfectly bent so that they could be assembly lined in manufacture. So I had to design a process to organically bend, I think it's 133 wires. You know, it's a delicate metal frame, and it's going to be taking a lot of impact many times over time from metal balls moving at quite speed. So we needed to figure out if the aesthetic we had chosen of the like birdcage look could even stand up to the abuse of the machine. So I had to put together a prototype so that we could at least do some tests to figure out if we needed to swerve drastically in concept or if we could push that idea to its full fruition.
I always thought that hand bending the wires was going to be difficult, but once Ecco actually did some testing and actually started to hand bend the wires, we found out that it was not a realistic task. Luckily enough, Martin was reached out to by DI Wire, which is a CNC desktop wire bender.
Hey, it's Marco Perry here at Pencil Labs in New York City. We're going to use the DI wire to bend up some marble funnel parts for the Marble Machine X. Let me show you how we make these. We're going to shut off the protrusions. You can see these are all made of these curves. So that's what we're interested in because that's the center line of the wire and that's what we bend from. Okay, we're ready to hit bend. Okay, that's the first one. 21 more times to get your basket, 15 baskets, and we'll be ready to ship everything over to Martin.
The thing about metals is they really like to be fused to the same alloy, and they put up a lot of trouble when being fused to disparate alloys. So when manufacturing these funnels, we run into interesting problems with what is easy to machine versus what is easy to weld. And those are two very different metals. So we chose stainless steel, which is a very hard metal to machine, but it's very easy to weld. We presented huge challenge to the machining process in favor of making it weldable at all. Welding is an atomic level fusion. It's when you get all the atoms soft and they all blend together and they have no idea who was what before they all got hot and mixed together. Brazing is a superficial weld. It's a topical weld. It means the atoms don't actually blend together. You have two different metals and one of them makes a skin around the other and they don't actually make an atomic bond. It's sort of a lot more like glue than it is like a weld. It just happens to be made out of metal.
So my name is David Lewis, and I am a CNC machinist. So currently I work at SpaceX in Los Angeles. My relationship with the Funnels project has been really just at the very beginning, talking about what kind of materials and processes seemed to me at the time the best way to connect stainless steel wires of a small gauge without destroying them. I gave Martin some advice. I guess he went with it, and it sounds like it was a success. I have some experience with what's called TIG brazing, right? And TIG brazing is using a TIG welding torch to melt what is really a filler material that is not welding. It's brazing. And brazing and welding, traditionally you think of one with a flame and one with a electrode. But TIG brazing takes the two together. Yeah, so when I spoke to Martin about the funnels, you're talking about a small mass of metal, in this case stainless steel, and taking that and joining it to another part that was quite small. And so neither part can really absorb the heat of the torch very well. When you're welding, you have to pick which one you're going to melt into the other one. And the problem is when you have two parts that have very little mass, essentially you'll just see them both vaporize in front of you and you have no weld at all, actually. And so brazing allows you to avoid that altogether by picking a third material with a lower melting temperature. So when you're taking two stainless steel wires and joining them with brazing, you're just eliminating the threat, so to speak, of losing the joint based on melting it back.
So we ended up moving from the silver braze to a silicone bronze, which is kind of in between the two in terms of its temperature preference. It's a little more tolerant. It has a larger temperature window, and it's a much more coagulate fusion metal. So it does a lot of gap filling, and it sort of reaches its way towards the heat for you, which is helps you kind of smear the heat around less precisely. So it turned out to be the most forgiving of all of the fusion techniques and the one we used on all the funnels in the end.
It's just been a very collaborative project, and I've really enjoyed it. The artistic vision sometimes gets in the way of practicality, but it was really cool to watch myself, an engineer, Tim, a fabricator and engineer, and the artist side of Martin sort of kind of have this back and forth with, can we make this slight compromise to make it easier to manufacture? And more often than not, the answer from Martin was no. And so then we had to like dig even further into our engineering ideas to make it work. It came out more beautiful than I could have initially thought it would have. And I think a lot of that's thanks to Martin being like, no, I want it to look this way. I'm not advocating that that's always how it should be, because sometimes practicality should rule. But in this case, it worked out really, really well.
I mean, we did it. The funnel project has been like a miniature version of the full MMX project because my artistic vision has really clashed with engineering reality. And it's only thanks to the heroes in the funnel team that we managed to pull this off without me having to kill this darling. And we achieved, in my eyes, a no compromise design, which is, of course, what gives meaning to life itself. So I want to say a huge thanks to everyone involved for volunteering your time and expertise to this mission. Jacob de LaRocca has been sort of a project manager for the whole project and did heroic CAD work. Tim Keller, who like Gandalf threw himself down in the machining abyss to fight the stainless Balrog, and Professor Philip Brown, who after seeing the first concept created the most exquisite creative imaginary designs, where we in the end stayed with the first concept. Ecco Pierce built a prototype manually, which taught us everything we needed to know about how to put these funnels together. David Lewis suggested the life-saving Silicone Bronze TIG Brazing method. I was failing severely with the silver brazing, and when I switched to Silicone Bronze TIG Brazing, things just worked out right from the start. Last but not least, the amazing team from Pencil Labs. They reached out to us the same day when we decided to try to go for CNC wire bending, and the DI wire is such a beautiful machine, and I want to thank the whole Pencil Labs team for bending the 400 wires for the funnels on the DI wire. I'll leave a link in the description to everyone in this US-based funnel team so you can connect with them directly. By the way, I managed to save the funnel where I tried silver brazing. Here are the two funnels I made so far side by side. You can see how repeatable the design is now. I have 13 more funnels to assemble. The learning curve to put the first ones together was steep, but I think for the next 13 it will be easier, although a mammoth task, and it will take quite some time to do them all. Thanks to everyone following and supporting this build, and a special thanks comes from my niece, because I've been picking up marbles from the floor like every day for the last 5 years, and I'm very happy to have these beautiful sculptures picking them up for me instead. Good luck with everything you're doing, and see you next week.